So guys, when we finished up the last class we had, we were discussing emission spectra. For a solid or liquid, if you get it to emit light, you will always get a continuous spectrum regardless of what type of solid or liquid you have. If you have a gas though, and you pass it and do the same thing, you excite it or pass electricity or supply energy to it and it gives out light, and you observe its spectrum, you end up with a line spectrum, and each atom has its own unique line spectrum. Now Niels Bohr developed a theory around that as to why that was, and he suggested that if you supply energy to an atom, some of that energy might be absorbed by electrons and it can jump out to a higher energy state or move out to a higher orbit. And when it jumps back in again after losing that energy, it emits that energy in the form of electromagnetic radiation. And there's a formula there, HF equals E2 minus E1, to work out what that energy is. And each atom has its own unique set of orbits. That's why you get a different frequency of light from each individual atom. An application of that was lasers. And you can read about that there. Now I just want to move on though to the next section. So you need to know some stuff about where lasers are. So again, so it starts off here pretty nice. You need to know a bit about the structure of a nucleus. So you've got the proton, neutron, electron. The electron is very small, it orbits the nucleus. The proton, neutrons are contained inside in the nucleus. That's all pretty handy stuff you've met before. The atomic number of an element is the number of protons. The number of protons is important. The number of protons decides what type of element you're dealing with. So if an element for any reason loses a proton, then it's changed to a different element, and we'll see that later on why that's kind of significant. And then the mass number gives you the number of protons plus neutrons. Now your maths tables are pretty important here. This is page 79, and so the atomic numbers are on the top here and the mass numbers are on the bottom, and you round them off the nearest whole number if you want to work out the mass number. So for example, the mass number of aluminium is 27. Just get back to the book here again. So that's all fine. And then isotopes, so elements that have the same number of protons but different number of neutrons are called isotopes. Now in 1896, Henri Becquerel was experimenting with uranium salts, and he found that a photographic plate nearby went black, which meant that the salts must be emitting something. So he basically is credited with the discovery of radioactivity. So radioactivity is the disintegration or decay of the nuclei of certain atoms. Now you must state nuclei when you're defining it. It's the decay of the nuclei of atoms with the emission of one or more types of radiation. And there was 3 types of nuclear radiation discovered: alpha, beta, and gamma. So what they would have done was they would have gone and experimented with magnetic electric fields. So we can see here on the right that an alpha particle must be positive because it's attracted to the negative electric field. A beta particle must be negative as attracted to the positive plate, and gamma rays shoot straight through in both examples there. And then over here we have the penetrating power. An alpha ray can be stopped by a sheet of paper. Beta ray can be stopped by a thin sheet of aluminium, and it's quite difficult to stop a gamma ray. You need either thick concrete or thick lead. And again, the ionizing ability is actually in reverse. The alpha rays are the most ionizing and the gamma rays are the least. Now, if later on we meet a Geiger-Müller tube that's used for detecting radiation, in all these experiments, the first thing you must do is get the background count rate, and then you subtract that away from any further calculations. And so you can reach the experiment there yourself. It's nice and straightforward. And the same with the next experiment here. Demonstrate the ionizing effect of radiations. You'll find if you use a radioactive source that has alpha particles that it will collapse the leaves the quickest. So again, the radiation ionizes the molecules above